Okay, now that's some of the direct metabolic benefit of the products of the fermentation. But also the bacteria themselves can provide a benefit to the body because after all, if we're eating fermented foods, the bacteria are there. You know, when you're drinking an unpasteurized kefir, for example, or unpasteurized kimchi or sauerkraut, so pasteurization would kill all these bacteria. But if it's unpasteurized or raw, then you are consuming the bacteria as well. So now you have the magic of the probiotics. So fermented foods contain live bacteria, if they're raw, that can help balance the gut microbiota, improving digestion and even other things like immune function. So numerous benefits. And of course, probiotic supplementation, particularly if you know you're actually getting live bacteria, have been shown to be very therapeutic for myriad gastrointestinal disorders and autoimmune disorders and even metabolic function as well. So just as a personal preference, when I'm focusing on fermented foods, and I'm not giving anyone any advice, of course, in this regard, but I like to, when I can, focus on raw and unpasteurized sources. Now, some of all of this I have discussed in various venues before. So some of you who have been connected with me for some time might not deem any of this to be particularly novel, and now you're clamoring for something new. Well, let me give you something new that you might not have heard me discuss before, which is anti-nutrients. I've certainly never discussed anti-nutrients in the metabolic classroom previously, at least I don't think I have. But anti-nutrients are worthy of discussion, and they're also, of course, first and foremost, worthy of defining. So these are natural occurring compounds found in various plant-based foods, and they interrupt the absorption and utilization of various nutrients that we consume. This includes things like minerals or proteins or other nutrients that we would want to be absorbing, but these anti-nutrients literally bind them and block them from coming in. Well, needless to say, that's not optimal. Because there are some of these things like iron and zinc, for example, magnesium, there are minerals that we need, and proteins. These are things we have to get in. That's why we're eating that particular food. It's to get things like this, macro and micronutrients. The anti-nutrients get in the way. Now, what are some examples for this? Because it sounds like it's made up. But just think about this for a second. If we were dropped in the middle of an unfamiliar forest, and you would say, well, look at all these plants we can eat. In fact, the reality is, at best, we would get no benefit from virtually all of them. At worst, they kill us, they poison us. Plants can't run away like an animal can. The animal's defense is its ability to get away from us or attack us back. A plant can't run away, but it can attack us back, even if after the fact, by consuming it. It wants to make us regret it and ensure that we don't come back and do it again. Now, in our intelligence, we have selectively bred certain plants to have much more modest levels of these anti-nutrients, but they are molecules that are inherent to all plants. Now, I don't mean to imply that a human can't eat any plants and be healthy, but I hope that there's an implication that plants do contain molecules that would want to discourage us from eating them. And some people may be particularly sensitive to those molecules. Now, what are some of them? I could just find and think of really 4 easy examples and obvious ones. One of them is phytic acid. Phytic acid is found in seeds in particular, and nuts and grains and legumes. But what it can do is bind minerals like some I mentioned, calcium, iron, zinc, and prevent their absorption. So it keeps them in the gut to just be excreted in waste from the intestines. So foods that are particularly, or diets that are very reliant on these kinds of foods, nuts, seeds, legumes, they may be getting unhealthy levels of phytic acid and then may be developing slowly a deficiency in these minerals, calcium, iron, zinc. Another form of an anti-nutrient is lectins. Lectins are proteins found in legumes and grains that can interfere with the absorption of nutrients and still cause some distress. Another one you've possibly heard of is oxalates. Oxalates are particularly enriched in leafy greens, also nuts and seeds, but they bind to calcium and prevent calcium absorption. But at the same time, if the oxalates get into the blood, they can form these crystals, which can lead to stone formation. It's almost like their own version. This is like an oxalate version of gout. So a lot of people who suffer from frequent kidney stones will often be told to avoid foods that are rich in oxalates, like leafy greens, nuts, and seeds. Now, the last one is tannins. Tannins can be enriched in teas and coffees, but they are iron blockers. They don't want the body to absorb iron. And if there's a lot of tannin consumption, this can be a concern for people who have low iron already, or it can cause the low iron. Now, why am I bringing up anti-nutrients? What's the point? Well, there is wisdom in the way our ancestors used to eat these kinds of plants, including things like coffee. Why do we ferment the coffee beans for a period of time? Because fermentation will remove anti-nutrients, thereby improving the bioavailability of the essential nutrients that we want. So with each of these ideas in mind, during fermentation, the activity of the phytase enzyme increases. So fermentation increases this the ability to degrade phytic acid, and it breaks it down into its component parts, in particular, in this case, inositol and phosphates, which are both perfectly benign molecules. In fact, in the case of inositol, it's even beneficial. So when we are consuming the grains and legumes and other sources of phytic acids, if we have allowed the food stuff to undergo fermentation, now we have a greater absorption of those minerals that the phytic acids were attempting to block, namely iron, zinc, and calcium. Fermentation can also degrade lectins, which are these proteins, like I mentioned earlier, that can bind not only to the intestinal lining, damaging the lining and increasing the tendency for leaking molecules in or bacteria in, but it also will affect nutrient absorption. And the microbial activity during fermentation will break down these lectins, reducing that anti-nutrient effect. And the same thing goes with tannins. Tannins are also reduced, which can help improve iron absorption, a very important micronutrient or mineral, and even oxalates. Fermentation has been shown to lower oxalate levels in foods from like leafy greens and grains. These microbes will just take the oxalate and break it down, preventing the oxalates from, in turn, preventing this antagonism towards nutrient absorption. Now, there were a handful of studies that I found that actually documented some of the reductions, and just some of them are worth noting. Like, for example, cassava. Cassava is a starchy plant that is eaten in various parts of the world. The fermentation of cassava using bacteria can actually reduce some of these anti-nutrients to significant levels. Like, for example, cyanide. Yes, cyanide that can poison and kill you. Cyanide is present in cassava. Well, under fermentation, cyanide levels are reduced by 86%. Tannins are reduced by 73%. Oxalate is reduced by 61%. Phytic acid is reduced by 72%. That is some substantial reduction in some pretty harmful molecules. Also with legumes and cereals, that if you allow these grains and legumes to undergo fermentation, phytic acids will be reduced by over 50%. Lectins from fermented beans were found to be down by 95%. So you're cutting it in half. And you see this reflected throughout myriad other examples of fermented foods. So all of this, I hope, is just impressing upon you the relevance and even, dare I say, importance of fermentation when it comes particularly to these starchy, sugary foods. Now, let's sum it up as we wrap up the lecture. Over the course of what we discussed today, we talked about just what fermentation is, particularly how bacteria can come in and eat up the glucose sources, the sugars and the starches, reducing the amount of glucose our body has to deal with and the subsequent insulin spike that would come with it. At the same time, while it is removing the stuff we don't want, because remember, there are such things as essential fats. There are such things as essential proteins or amino acids. There's no such thing as essential carbs. Now, again, I'm not saying we can't eat them, but how awesome is it that these bacteria have come in and removed the one thing we don't need and replaced it with other beneficial things like short-chain fats. And I listed some of the benefits of short-chain fatty acids. Also, if we're consuming the raw fermented food, we're getting probiotics as well. So we have the additional benefit of putting some new healthy bacteria in our intestines, which helps the overall health of the microbiome, which in turn helps metabolic and immune function. Also, the last point we discussed was the removal of anti-nutrients, these almost mythical little monsters that are inherent in all plants, but ideally in profoundly lower levels. Like usually fruits have lower levels. You'll notice not one time did I mention fruits here. So not all plants are the same when it comes to these anti-nutrients, but our ancestors were wiser than we give them credit for, and often they would bury these things in a little pit and sprinkle some other stuff on them, or even use their own spit to get bacteria in these little stewing little pods of fermentation, and then get it all up and dry it and eat it. So what can you do about this? My advice would be to find a way, if you're so inclined, to incorporate some fermented foods. I've already mentioned my favorite. I love kefir. I also love sauerkraut. It's one of my favorite things. So in my mind, focusing on fermentation fits very well into my first cardinal rule of eating smartly and increasing your insulin IQ, namely focusing on fermentation and being a part of controlling carbs. Thank you for joining me. Until next time, more knowledge, better health.